You start.
Okay, sir. Very good morning to you, one and all present here. It's my honor to introduce today's second session resource person, Professor R.S. Soundariya, ma'am. Professor R.S. Soundariya is an assistant professor in the Department of Computer Science and Engineering at Bannari Amman Institute of Technology, Sathyamangalam, where she has been since 2017. She had worked in cognition technology solutions as a programmer analyst trainee from 2014 to 2015. She completed her undergraduate studies at Hindustan Institute of Technology and postgraduate studies at Coimbatore Institute of Technology. Her research area lies in the area of sentiment analysis using machine learning techniques and deep learning frameworks from theory to design to implementation. She has actively involved in consultancy projects in other disciplines of computer science, particularly data analytics and exploring the patterns in real-time data. She delivers lectures in various institutions for the benefit of students and faculty members. She actively participates in workshops and training programs. She has published papers in Scopus Index journals and presented research articles in various national and international conferences. She has also contributed for book chapters regarding artificial intelligence and COVID diagnosis. She has filed two patents on the applications of Internet of Things and artificial intelligence. We welcome you, ma'am, for this session.
So thank you, Tuno, for the wonderful introduction. So a very good morning to one and all present here.
Madam, you start presentation, no problem. Madam?
Oh, okay, sir. Okay, sir. So a very good morning to one and all present here. So I hope my screen is visible.
Yes, ma'am.
Okay, Tuno, thank you. Thank you so much.
Okay.
So before directly going to the topic, let us try to have some basic exploration related with the topic. So on your screen, you could see a question like, how do you choose a best product or a good movie or the best sellers in the market? So this is a question like, what are the answers that you can get when you see this question? How do you choose a best product or a good movie or the best sellers in the market?
Customer reviews.
Okay. Any other answers?
Recommendation.
Recommendations. Okay.
Ratings, ma'am.
Sorry.
Ratings.
Ratings. Okay. Okay, fine. Good. Thank you all for your wonderful answers. Yeah, brand and experience to quality, advertisement, selling rate, everything. Wow, I'm getting a lot of wonderful answers from you all. So thank you, professors. So exactly, yes. So these are the things that we do before going to buy any product. For example, now we are living in a world with full of technologies everywhere. So we are checking ratings, reviews everywhere, everything. So in the previous days, or where our parents were, or our even our ancestors were there, what they used to is they used to check with their neighbors or their friends and their families. So for example, if a new shopping place or a shopping shop opened in our locality, so what we do, we just check with whoever visited the shop, we get some opinions from them, right? So in nowadays we go for everything in online, like we check the reviews, we check the ratings, everything we do. Okay, so it is all about the data which is going everywhere, and it is also very helpful for us in understanding certain things or understanding certain outcomes of a product or a movie or whatever it may be, with whatever it is. For example, if the Samsung or if Apple launches a new mobile phone, so if they want to identify like how the phone has reached the customers or not, so obviously they check the review. Okay, so here comes the today's topic. Okay, so sentiment analysis. So basically the sentiment analysis can be used in order to explore or discover people opinions or emotions and the feelings about a particular product or service. So these are actually a basic concept about sentiment analysis, and the applications are many things. Okay, so for example, if you take opinions alone, there can be lot of applications. For example, like market checking the customer feedback analysis, and checking the brand monitoring a brand of a product, etc. So that is one particular application, a wide application actually. And if you take emotions and feelings, and that can be considered as another one wide area. For example, emotion recognition, emotion detection, like whether that particular person is happy or sad or angry. So all these things comes under the topic called sentiment analysis. So the plan for the today's this 1.5 hour session is like, first we'll be starting with the overview of NLP and sentiment analysis, and we'll be discussing what are the different variations we have in sentiment analysis. So basically it is all about checking the reviews, finding the opinions, emotions, etc. So in that, what are the variations we have, so that we can discuss in different variations of sentiment analysis. And for movie reviews, and today's application portion I have taken is movie reviews, like how it is happening. Okay, so we know what is movie, or like how the sentiment analysis is happening. So just let us understand with a few simple steps how it is actually happening. Okay, then the application areas, and finally online sentiment analysis tools. Okay, so where just like before, like 3 to 4 years before, we had no online analysis tools, but today, in today's world, we have a lot of online analysis tools, whatever it may be, even for it may be a prediction or whatever it is. So we will just see what are the online tools that we have for sentiment analysis. Okay, so this is the outline of the today's talk. Okay, so just let us start with the NLP. So now we know what is sentiment analysis, but we should know where is this particular sentiment analysis is actually originated. Yes, so it is all from NLP. Okay, so we all know about NLP, like NLP is natural language processing, and obviously yes, it is a branch of AI. We all know that. And what is the use of NLP is, so the what NLP do is it helps the machines to understand the natural human language. That is why it is called as natural language processing. Okay, so we are making the machines to understand the natural languages. It may be of in any form. Okay, and the very own example if you take for NLP is the suggestions. So whenever you type something in the keyboard, it automatically suggests, right? So this is one excellent application of NLP. Okay, so can you say some other examples of NLP, like which we face in real time? Any other applications of NLP?
Chatbot.
Yeah, exactly. Chatbot is an excellent application. So nowadays, if we go for any sites, there's always we have a chatbot. Okay. So in previous days, there will be some representative, customer representative, like we have to make them call and we have to ask them whatever it is. But today they have chatbots in the form of human, which exactly replace whatever we ask. Okay. Any other applications other than chatbot? Any other applications? Okay, fine. Let us just, as slides move on, let us just discuss from interesting applications of NLP also. Okay, so why NLP is important? So actually, okay, fine. We are making the machines to understand what the human language, everything is okay. But why actually that is needed? Okay, so the most important reasons as per the literature is the large volumes of textual data, and another one is structuring a highly unstructured data source. Okay, so you all know, like in the today's technology world, there are a lot of data getting generated in every second, every microsecond, every nanosecond. Okay, and we humans, like even yes, we also can monitor the data, can collect the data, everything we can do, but these pretty excellent machines are much capable of analyzing the data more faster than human. Okay, and that's why we are going for this NLP. We need a machine to process all the data, whatever that is generated. Okay, and another one is, you all know, the whatever data that is generated, it is actually in different structures, or I can say it is in different data types, right? So in order to manage all these things, we need something called as NLP. So actually, currently two applications I'm getting in mind. So for example, let us take WhatsApp. Okay, so we all use WhatsApp every day. Fine, almost 95% of the people in the country uses WhatsApp, and lot of data is generated in WhatsApp. Even in a single text message you send, or an image you send, or a call you make, or you share any documents, so everything are the data that is generated. And if you see the data, all these data are in different format, right? So these are the large number of data available. And another application is Hike. So I think many of you will be knowing about Hike. So Hike is also similar to WhatsApp, but in Hike we call someone called as Natasha. Do you know her? Have you used Hike, and do you know Natasha from Hike? Anybody? Anybody? Hike Natasha?
No, ma'am.
No. Okay, fine. Okay, fine. So, okay, fine. So please go and check. Hi, Natasha. That is actually very interesting and funny portion in the Hike. Actually, in Hike is also like a messaging platform like what we have in WhatsApp. The one added functionality of in Hike is there is someone called as Natasha is there. It is actually a bot which is designed, which was designed by Hike. Okay. So what happens is it automatically send messages to us. For example, if it is any Dasara or any Diwali festival is nearing, it just sends some wishes. And also not only wishes, for example, if you felt boring or if you felt sad, you can just text to Natasha and it will also be replying whatever you ask. Okay, so it is actually one funny and interesting application. Okay, so please try that. So that is also another example for NLP. Okay, so we know chatbots, and these are the chatbots which were already designed, and they were circulated among social media. Okay, so if you have a chance, just install Hike and have fun with Natasha. Okay, so now back to the presentation. So these are the reasons why we need NLP. Okay, I don't know, one second. Fine. So we are dealing with large amount of textual data, and every data we deal with is actually unstructured. Fine. So here comes the some of the NLP applications. So sentiment analysis. So that is what we are going to discuss today. And another one, the one from one of the fellow participants I get, it is chatbots. Obviously, chatbots and some virtual assistant, and text classification. So if you're giving a text and classifying that into depends on the polarity or depends on the requirement, and machine translation. So definitely you would have tried this. If you're not tried, you just go and try in Google. So if you want to convert some from a particular text from Hindi to English, or English to Hindi, or Tamil to English, whatever it is, you just type the text and then convert into select the language, it will automatically translate it. That is also one such very excellent application of NLP. And market intelligence. So here comes the lot of uses of sentiment analysis or NLP. Okay, as previously I got many answers from the professors, like checking the reviews, brands, everything. So those comes under market intelligence. So let us discuss about this in the later part of slide. And finally, speech recognition. Okay, so all these things are some good and excellent, interesting applications of NLP. So of this today, we are going to just discuss about sentiment analysis. Okay, so basically what is sentiment analysis? So obviously, yes, it is a text classification task. What do we do is we will be given a text and or some list of phrases, and out of that phrase we have to find, or the classifier have to find what is the particular sentiment it belongs to. So here the word sentiment refers to, like, it can be a positive that particular sentence can be a positive sentence, or the particular sentence can be a negative sentence, or it can be a neutral sentence. So that is the role of the classifier here. So the text classification, the text classifier should classify to which sentiment the given sentence belong to. Okay, so this is just about sentiment analysis. Now, like, we have three phrases. Okay, so first one, Titanic is a great movie, and Titanic is not a great movie, and Titanic is a movie. Okay, so what can you infer from these phrases? Anybody? What do you infer from these three phrases? So Titanic is a great movie, is a not great movie, and is a great movie. So what can we infer from these phrases?
Positive, negative, as well as neutral.
Yes, exactly. Yes. Any other answers? Yes, exactly. Impression of the movie on the person. Exactly. Very good. Very good. And it is a movie, obviously. Yes. So different perspectives of the film is exactly neutral. Oh God. Okay, fine. Yeah, okay. So thank you for the answers, professors. Yes, exactly. So it has got some set of sentiments actually, right? Yes. So how do we analyze the sentiment? For example, we have got 3 different reviews from different persons, or maybe some from same person. That doesn't matter. So here the main thing is, how do we find the sentiment? Okay. So as humans, we can find by just simply reading the phrase or reading the text. But the actual challenge is we have to apply the same human knowledge to the machine. So how can we do that? Okay. Now, so here there are some words highlighted. Can you see? Titanic is a great movie, it's not a great movie, and is a movie. Okay. So when you see the highlighted words, it is actually nothing like, it denotes the sentiments. Okay. Fine. So first of all, these phrases are nothing but some reviews, okay, about a movie. And here when you see the first phrase, it shows a sentiment called great. Okay. So when we have the great, there's a sentiment great, so it denotes that that particular phrase or sentence is a positive. And the next one, not great. Okay. So that denotes negative. And the third, when you go to the third one, it is like you cannot come to a conclusion like whether it is a positive or whether it is a negative. So it can be come under the called under a category called neutral. Okay, fine. So this is how the sentiment analysis works. So if you want like movie reviews, like you want to go for a lot of movie reviews, you can check this site Rotten Tomatoes. Okay. So when you check so if you see the screen, you have 2 examples, positive and negative. They themselves have given which is positive and which is negative, and they have given some keywords why this particular review is called positive and why this particular review is called negative. When you see the positive side, the highlighted words are insight and top. When you see the negative side, the negative sentiments are problems and mediocre. Okay, so this is how we have to begin the sentiment analysis task. So we have to identify the sentiments that denotes the subject, whether it is a positive subject or negative subject. Okay. And here are some of the variations of sentiment analysis which I was talking about. So we have got some 5 different variations, okay, like standard sentiment analysis, fine-grained sentiment analysis, emotion detection, aspect-based sentiment analysis, and the last one is intent detection. So the first one, standard sentiment analysis, just what we discussed in the Titanic example. Okay, it just will give you the opinion. What is the sentiment or nuance beyond the opinion? Okay, and it just classifies whether it is positive, negative, or neutral. Fine. Now, what is this fine-grained sentiment analysis? Okay, so it just gives you a detailed opinion or detailed classification. Okay, that is why it is called fine-grained. Instead of positive, negative, neutral, it just goes to very positive, positive, very negative, negative, and neutral. Okay. So for example, like these are the sentences they have given. Fine. Could see negative, very negative, and neutral. Okay. Now let me ask you a question here. On seeing this 5 keywords like very positive, positive, neutral, negative, very negative, what comes in your mind? Actually, there is one application similar to this. Can you just recollect the everyday application, I can say, or that is something related to this STTP also? So I assume this STTP is going on for the 6 days, and we use this related application in all the 6 days also. Can you guess what it is then? So here they have given 5-star ratings, like, right? So similar to this, we are also doing one particular application with some 5 set of sentiments, I could say. Daily, from the day 1 till the day 6, we will be doing that application.
Yes, feedback.
Yes, exactly. So in the exactly, thank you for the wonderful answer. So in the feedback form, we have no agree, disagree, okay, neutral. So we have some 5 categories, right? Exactly. So that is one example for fine grained sentiment analysis. Okay, so you just modifying the traditional sentiment analysis, that's all. Next one, emotion detection. So as I said earlier, so it is about detecting the emotions, like in the form of the anger, whether they're anger, whether they are happy or frustration, sad, disgust, etc, etc. We have lots and lots of emotions, right? So this model, this particular example or application will help you in detecting emotions. Okay, and that can be done either from a piece of text, or there are also some other inputs we have for this particular application, emotion detection. Okay, then aspect based sentiment analysis. So from the name itself, it says it is based on some aspect. Okay, so based on some particular properties, we are going to find the sentiments. Okay, if you just see the example, or let us just take the product reviews. Okay, so if you are discussing about a product, you use some different aspects, like in the aspects of price, in the aspect of the camera quality, in the aspects of the battery life, or in the aspect of the UI integrations, whatever it is. So these are called aspects. So based on that aspect, we are taking some decisions. So if you see the example, SurveyMonkey has a very clean and user-friendly UI. Okay, so this here, SurveyMonkey is the entity which is about, on which about we are talking, and very clean and user-friendly UI. That is the opinion. Sorry, very clean and user-friendly is the opinion, the sentiment which you are finding for the answer, and the UI is the aspect which we are talking about. Okay, and based on this, what we can take, what the conclusion we can take? Yes, it is about a positive sentiment. On which aspect? On the aspect of UI. Okay, so this will give the this will give the manufacturers or the analyst more detailed sentiment analysis about some each and individual features. So this is about aspect based sentiment analysis. And the last one is intent detection. So we are going to just find some actions behind the opinion. Okay, fine, this has happened. So what is the next that has to be done? See the example, you will understand very clearly. Very first, frustrated right now, Instagram keeps closing when I log in. Can you help? So this is from a user, from an Instagram user. So this is about a negative. So fine, it is a negative sentiment. So what is the action that has to be taken? So immediately request for assistance. So this is called intent detection. Okay, we are finding some sentiments, positive sentiment, negative sentiment, or neutral sentiment. What action has to be taken? So that is called intent detection. So this is all about the different variations we have in sentiment analysis. So here is the simple representation of how the sentiment analysis works. So first it starts from text input. So we give a text input. The next what happens is tokenization. So can you just say what is tokenization? Any idea about tokenization? Anybody about tokenization?
Splitting into words, dividing that sentence into
Pre-processing statement.
Exactly, madam. Exactly. Thank you, professors. Exactly. So the tokenization is the process which, like, we will be splitting the entire phrase or a sentence into individual tokens. We can call that as a word here. So here we are giving the input as in the form of phrases or sentences, right? So now we want to split it into some individual tokens. So that process is called tokenization. And next comes stop word filtering. So stop word filtering is like we can remove the unwanted words, stop words, and the, so those things can be eliminated, right? So as far as your sentiment analysis is considered, we need the words which gives you the sentiment. That's it, right? So we do not want is, was, the, everything. So just remove, we have to remove it. So that is called as stop word filtering. Fine. And negation handling. So negation handling is like not, couldn't, never, those things. So we can just remove those words. Then next comes stemming. So stemming is actually the purpose or the clarity behind stemming is we have to reduce the size of the vocabulary. For example, there is a sentence, he is watching a movie. So what is it? He is watching a movie. Fine. So we can remove the suffix ing from the verb watching. So we need watch. Okay, that's fine. So we can remove the suffix. So that thing can be done with tell me. So we are doing some basic process or pre-process. One of my professors said pre-processing. Yes, exactly. So we are just doing all the pre-processing, and then after extracting the required features or the required words which gives you the sentiment, we go for classification. And after classification, what happens? We get the sentiment class, whether it belongs to positive or whether it belongs to negative. So this is just an overview of the basic sentiment analysis process. Now, let us just understand the same concept in detail, like how it is happening. Fine. Like what is behind the behind sentiment analysis. So this is a simple and sample model. Okay, we are collecting a data, we are preparing the text. How do you prepare the text? By some pre-processing techniques, we just make the text ready for the classification, whatever we discussed in the previous slide, like tokenization, stop word filtering, negation, everything. So we just do all these things to the input text and make the text ready for the sentiment detection. Then we apply some classifiers and we classify and finally output. So this is a sample and simple model. Now let us understand the same a little detail. Got it? Okay. So these are the steps, like steps, or I could see some, I have just summarized some phases. Okay. So the first one, formulating the problem statement for sentiment analysis. So as for the examples we discussed now, we know how we give the inputs in the form of some sentence and text. Okay. So as a human, so we can understand those texts. Now we want to make the machine to understand. So we have to represent in a machine understandable way. So that is about formulating the problem statement. Next one, intuition behind sentiment analysis. So fine, we are done with the problem statement. So what is next? So what is the next things we have to do? So that is about intuition and bag of words representation. This plays a major role in sentiment analysis. We'll study in detail. We'll discuss in detail. And we are making the training set ready. So when whatever machine learning model you have to go for training set, testing set, data set, entire. Okay. So you have the data set and you're just making the training set ready. And classification. So this is obviously a classification task, right? I hope everyone will agree. Fine. So as today, I'm just discussing that classification with naive. So we can apply either SVM or either KNN or either random forest, whatever it is. But in today's session, we are just discussing how naive will work. And then finally, some sample code for Python implementation. So this is these are the steps through which we can understand how a sentiment analysis process is happening. Okay, so the first one, formulating the problem statement for sentiment analysis. So now, okay, so the input is a document D and a fixed set of classes C equal to C1, C2, etc. Fine. So can you see what? Can you just say, or can you just identify what is D or C? Any guesses? Can you just guess what is this D and what is that C? What is D and what is C? Let me just share my screen again. See here, we have given input a document D and a fixed set of classes C, C1, C2, etc. up to Cn. So what is this D and C represent? Any guesses?
Sentences in your document.
Yes, madam. Yes, madam. Exactly. So whether D or C, which represents the sentences?
C may be the sentences of your document.
Okay, ma'am. Any other answers? Let me just share you again. So we have a document D, a fixed set of classes C, C1, C2, etc. up to Cn. Okay. Can you say or can you guess what is D and C? D.
Otherwise, with respect to program, some header files like that also can be treated as
D, feedback, and C, class of sentiments. So feedback, I think, if I'm not wrong, you mean the input sentences? D, feedback means the input sentences? Yes, okay, exactly. So thank you all for the wonderful answers. So here, so the D is nothing but the documents. Sorry.
screen is not sharing.
Yeah, I think now it is fine.
Oh, it's fine.
Yeah, so the D is nothing document. So here we are going to feed the inputs in a form of a document that is called D, and the fixed set of classes. So whenever it comes to our machine learning terms and terminologies, wherever you see the word class, it is nothing but the labels. So here the labels are positive and negative. So that is the end output, right? So those are nothing but classes. So here we have classes. So positive and negative. So two classes. So a document D is nothing but your input, and the C is nothing but the classes. So the output, what you will get, some C1, C2 that belongs to the set of classes. So as far as your sentiment analysis is considered, you will have only two class labels. Okay, when you give the input, it will be given along with the output. Got it? So that is what we do in machine learning. So this is the D is nothing but documents. So now let us see what is the document. So we know we are going to feed some set of sentences, but here everything is like they have given document D. Now let us understand a little more detail what is D. Okay. So here the word D represents a document, and that document can contain some number of tweets or number of phrases or some part of the news article, whatever it may be, or a product manual, whatever it may be. But it denotes some sequence of words. So depending on the requirement, it varies. So if it is tweets, it's Twitter sentiment analysis. If it is phrases, it is just a normal sentence text classification or sentiment analysis. So when you frame the training set or you make the training set ready, you will have some number of labeled documents, because it is a supervised learning task, right? So labeled documents along in the combinations D1, C1, D2, C2, etc. up to DN, CN. So now in order to make the machine understand, we have a document 1 called D1 along with its class, whether that particular document belong to positive or negative. Okay, so that those particular sentences or belong to negative or positive. So this is how we are framing the problem statement. Okay, that is why we are mentioning it as a document D and a class C. So now let us start understanding the various intuition we have in sentiment analysis. As I said, we do not require these words like I, are, am. You agree, right? So these words can be removed, or we do not need some consider these words at all. And then we have to select the features. So that matters here. I was talking about the words, right? The words which gives you the sentiment, or the words which help you to understand the sentiment about a particular sentence. So that thing has to be concentrated. So with the help of your stemming or your stop word filtering process, you can remove the words I, are, am, etc. Now let us concentrate more on feature selection. So what is feature selection we do? We are going to identify the most appropriate or relevant features which will help you to identify the class label. For example, if it is a positive class label, what are the features can be helpful, like happy, it is good, unbelievable, wonderful, beautiful. So everything can give you these features can give you idea about positive labels. Got it? So what we are going to do is a handful of words in a phrase which take part in this and identify them and extracting them from the phrases. Okay, so this is what the next thing which you're going to concentrate. Okay, now consider the movie review. Okay, you just please take 2 minutes or 1 minute time, just read this review and just tell me what can you infer this. What can you infer from this? So this example is particularly given in order to understand more about feature selection or extracting the features. Okay, please read the full review and just tell me how can you extract the features, or what are the positive features you have, or if you have any negative features. Please go ahead. Please take a minute time to understand this example.
Positive review only, ma'am.
Yes, ma'am. Exactly. But how can you come to the conclusion like it is positive?
All features like all different words to represent.
Exactly, madam. Exactly, you're right. Let me check the chat box if anybody is giving the answer. Yes, obviously it is the positive word. Exactly. Yes, within the words. Okay. Yes, exactly. So thank you all for your wonderful answers. Yes, exactly. Different nice comments about the movie. Exactly. So much thank you for the answers. Let us just try to explore further. Yes, as you all said, yes, obviously it is a positive review. And here, this particular in this example, we are going to more understand how this positive sentiment is happening. Yes. So these are the words. So the words whichever gives you the nature of a positive sentiment are highlighted, and these are the features. Okay, so the bold words, whatever it is given, are the most important words which construct the positive nature of the sentiment conveyed by the text. Obviously, so as a human, see the how excellent we are. As soon as we saw, within a fraction of second we are able to determine what is that. But what is the challenge here? The same, we have to make the machines to understand. Okay, so they have got only 5 cents, and they are not brilliant like us, but we have to make them understand. Okay, so these are the words we found. Now we have to prepare a table like structure. So like for example, if you take the previous sentence, you have great, right? So great, it is repeated once. And the next word I have taken is love. It is also given one. Why, it is also, the occurrence of that word is also one. And when you take recommend, that occurrence also one. So similarly, you have to continue. You have to fix a table and just note down the occurrences of the individual words. Got it? For your understanding purpose, I have just given 5. So still we have got a lot more words also other than the 5. So you want to identify the important words that gives you the positive or negative nature of the sentiment and note their occurrences. That is what you want to do. Fine. So this particular representation is called as bag of words. So in the initially I was talking about no. So this is the major thing we want to understand in sentiment analysis. This particular representation can be called as bag of words representation. So what is bag of words representation? So it is used in a document which does not contain specific words, but all the unique words in a document and their frequencies of occurrence. This is what very important. Fine. So frequencies of occurrences. So the more and more the frequency, with the more and more clarity you will get. And basically, if you take a bag, so it can be considered as a set, right? Mathematically, if you can be taken as a set, and that set will not contain any duplicate words. So instead we are maintaining their occurrences, the frequencies of occurrences. So this is what we have a role of the bag of words representation in NLP applications. And coming to bag of words also, so we need not bother about the sequence of words. That is not important. The only thing we have to check whether those words are present or not. So the whatever words you found in the bag of words will now again create a separate feature set. That feature set will be in the form of like many movie reviews, that is in the form of documents, and then you are creating a bag of word representation for each of the document and then giving their label positive, negative. So can you see here? So this is how the training set should look like. So if you see document, you have some set of n number of documents and the words. So those words are nothing but we have identified those words like they are contributing for the or the features which is select contributing for the particular sentiments W1, W2, W3, etc. and the sentiment. And can you see the numbers are right, like 1, 2, 5, 8. So those are nothing but the frequency of occurrences. So this is how the training set of a sentiment analysis application will look like. And this representation can also be called as corpus representation. Bag of words representation, and from bag of words representation to the final corpus representation. Either bag of words or corpus you can say. Okay, now these rows, whatever you have in this corpus, they are nothing but they represent some independent feature vectors. about a particular document. So here it is about a movie review, and corresponding positive negative, they indicates the labels that can also be given as plus, minus, whatever it is. Okay, and the feature vectors are given individually as W1, W2, W3, W4. Till now, is that clear? Till now, is that clear? From the basic sentence input sentences and how it is, how we are finding the words, how we are converting that into bag of words and a corpus representation.
Yes, ma'am.
Okay, okay, fine. Okay, okay, thank you. Fine. Now let us see like how to just map this with a particular classifier. So what are the basics of a machine learning model or a sentiment analysis task? So first is like we collect the data and we prepare the data for the model to identify, or we prepare the training set. So now let us consider, let us assume that we have collected the data and we have also made the training set ready. So what is the next process? We have to make the classifier ready. Now today's session I have taken the classifier as naive Bayes, a simple naive Bayes. So can you share like what is, you have any idea about the naive Bayes or anything, whatever you know about the naive Bayes classification or classifier? Naive Bayes, about naive Bayes, or what is the any basic idea? What is the basic idea you have for naive Bayes?
Independent items, variables can be considered.
Yes, ma'am. Independent assumption. Exactly. Yes, ma'am. Thank you. Any other answers? Naive Bayes, or when the name like naive Bayes comes, what comes into your mind?
Probability.
Exactly, ma'am. Exactly, ma'am. Well said. Well said. Exactly. It is a
Probability
probability.
between independent variables, I think so.
Exactly, ma'am. Again, it is a wonderful answer. Exactly. Yes. So from the name itself, we can understand like the naive Bayes works with Bayes theorem, which is nothing but probability. Okay, and between some independent variables, whatever variables you are going to consider, there have a naive Bayes assumption, right? Like these variables are independent of each other. Okay, so here you have the basic Bayes theorem. P of C given D equal to P of D given C into P of C divided by P of D. So here the D represents a document and C represents the class, and all the other factors like a P of D given C is likelihood, P of C is prior, and P of D is a normalization constant. So this is the basic formula we have rewritten in the form of D and C just for our application. Now let us just try to understand what is this factors or this terminologies, P of C given D, P of D given C. Oh, so what are those? Let us try to understand. Fine. So let us start from the RHS. So you have P of C given D. So how do we read it as? Probability of the class C given a document D. So you have a document D, probability of that document belonging to a particular class. This particular term we called as posterior when it comes to neighbors. Okay, and then again we have something called as prior. You could see here P of C is given as prior, which is nothing but it is the original thing, original belief, or you could see the original label of a document, either it is a positive or negative. It is called prior. Then next one is likelihood. So likelihood is probability of a document given a class C. So when it comes to your naive Bayes or Bayes theorem, these three things plays a very major role, like the posterior, the prior, and the likelihood. So we want to find the posterior provided with the likelihood and prior. So you have these things like you have the likelihood, you have the prior. With these, you have to calculate the probability, that is posterior probability. So here we have something called as normalization constant in the denominator, which actually can be avoided. Got it? So the main things we have to concentrate is the prior, likelihood, and we have to calculate the posterior. Let me make it again more clear. Now what we are going to do is we are going to expand the base rule. So C map is equal to argmax P of C given D. So C map is not, it is like, it denotes the most likely class. So we call in I think it is in Greek, it is called as maximum a posteriori. So for our understanding, it will give you the most likely class. Now coming to the right hand side. So you have argmax. Okay, what is the use of argmax? Anybody? What is the use of argmax? Argmax?
Finding max.
Exactly, ma'am. Very simple. Finding the maximum one. Yes, exactly, ma'am. So here we have got things like negative and positive. So you have one set of documents with negative, and you have one set of documents for positive. Now what you want to do is you want to find which is greater. You have the probability of them. You have to find whichever is greater. So you need argmax. So argmax will give you the maximum label, maximum sentiment. Okay. And C, lowercase c belong to uppercase c, that is nothing but your set of class labels. And we are expanding the base rule. Like instead of P of C given D, if you just refer the previous slide, so what is P of C given D? Likelihood into priority divided into prior probability divided by normalization constant. So you just apply the same. And as I said before, the denominator can be avoided because it is going to be a constant. So you need not consider. So you can expand your base rule in the form of argmax. Okay, so the C map will give you the most likely class with argmax function. So we want to calculate P of D given C into P of C. So this is the portion we want to concentrate on. So now let us be still more clear and see how to find this P of D given C. Okay. So first, as I said, C map will give you the probability of the most likely class. This is clear. We already discussed. Okay, let us jump to the next. P of C given D. So here is the place where we are going to use the bag of words representation. So your P of D given C can be expanded as, so what is D? What is D here? Anybody? What is D here? So we have P of D given C into P of C. What is D here? What is D? D. We have P of D given C. So what is the D here?
Document.
Exactly. Document. Okay. So the document will be containing number of inputs, right? So those inputs can be represented as x1, x2, etc. up to xn. So D is nothing but the document and C is nothing but the class label of that document. So you are expanding the document D as x1, x2, etc. up to xn. Okay. So this is another step ahead of the base rule. We are further expanding the base rule. Okay, now what we have to calculate, we have to find the maximum one, which is giving you the highest probability. So what is P of C is? P of C is how often the particular class occurs. For example, imagine in your data set, it contains 60 positive sentiments and 40 negative sentiments. So what is the P of C value? P of positive value will be 0.6. And what is P of negative? It will be 0.4. So just like this, you have to calculate P of C. In our movie review application, we will be having only two classes, positive and negative class. So in case if your data set is containing 60% positive and 40% negative, that it's just a simple probability. So your P of positive will be 0.6 and P of negative will be 0.4. Okay, so this is a simple calculation for P of C. So now we know, now we understood two things. So from this formula, P of, please listen, from this formula of P of C given D, we are just expanding it to in the form of documents. So as per the base theorem. So P of D given C into P of C. And we all very well know that the document is a collection of multiple input sentences or input phrases. So you will have many number of inputs inside a particular document. So you expand it to x1, x2, etc. up to xn. So this is the second step. Now, for the understanding purpose, we should know what is P of C. Okay, so I told you it is just about you're calculating the probability of the classes, how much ever your entire data set is containing. Okay, now, so can you just say what is this P of x1 comma x2 etc. up to xn? We know, fine, it is like a collection of multiple documents. So can you just expand this in terms of individual probabilities? So my question is, can you please expand this P of entire expression into individual in the form of x1, x2, x3? How can you expand this?
P of x1 into P of x2 into P of x3 divided by?
Yes.
P of A into B formula, I think so.
Yeah, exactly. So P of, it can be x1 given C, x2 given C into x3 given C, etc. Okay, exactly, madam. Thank you for the answer. Okay, can you see this now? So we know what is P of C. It is the occurrence of the words in the given class. Now, just let us understand how can we do that x1, x2, x3. Yes, so this is what I was talking about. So we can just expand this into in the form of product rule. X1 given C into x2 given C into x3 given C. So this is how we have to calculate. We have to consider the individual inputs inside a document. Now let us try to understand still more. So I said P of C is nothing but the probability of occurrence of a particular class. Now you imagine you have 1000 documents, and out of the 1000 documents you have only 2 words inside the corpus. So you remember the corpus representation? We have a table like structure, right? Inside that we have set of documents D1, D2, D3 along with the words W1, W2 along with the labels. So that is what corpus representation. Out of the 1000 documents, you had only 2 words in the corpus. So they are good and awesome. And now coming to the next point, and out of the 1000 documents, 500 documents are labeled as positive and 500 documents are labeled as negative. And we know, and they say that only the 2 words inside the corpus are good and awesome, and they belong, sorry? Okay. And they belong to the particular label positive because it is good and awesome. What they say is 200 documents contain good and awesome. So now what we have to do, we have to find. So how do you find the probability? So P of good comma awesome belonging to the positive labels, it is 200 by 500. Can you understand? So if it is P of x1 comma x2 means P of x1 and x2. You have to consider both the inputs. So here we have got 2 inputs. So you just combine P of x1 comma x2 given positive. So it is 200 by 500. So this is how we have to calculate this entire P of x1, x2. You have, right? You expand in terms of product rule and then find how many words you have out of the entire corpus and you have to calculate. So this is how we have to calculate. So now we know how to calculate P of C and how to calculate P of x1, x2 given C. So this is the expansion in terms of product rule. Till this, is that clear? Any doubts you have? Did you understand how the classification is done? Sorry, how the corpus calculation?
Yes, ma'am.
Yes. So what is? Yeah, okay, madam. Thank you. So what? So can you please more be clear? I think Professor Guru Sinha, what is the doubt, or what? What is the thing that is unclear? No, oh, sorry, it is no doubt. Okay, sorry, I misunderstood. Sorry for that, sir. Okay, fine. So thank you so much, sir. Okay, next, so as of now, we know like how it is happened. Okay, how we can perform sentiment analysis with your naive-Bayes classifier. Now let us see how can we do the same with some inbuilt libraries we have. So when it comes to sentiment analysis, you have naive-Bayes classification. You can go for multinomial naive-Bayes classifier. So we have some three different naive-Bayes classification like Gaussian naive-Bayes, Bernoulli naive-Bayes, and multinomial naive-Bayes. And when it comes to text classification related tasks, you can obviously go for multinomial naive-Bayes classifier. And when it comes, sorry,
So,
sorry.
அதுக்கு போயிட்டு போயிட்டாங்களா போயிட்டு போயிட்டாங்க
Ma'am,
அழகா சொல்லிட்டு
I'm sorry, I'm not getting. Your voice is getting break.
இங்கேயும் அதேதான்.
Madam, one doubt, madam.
Yes, ma'am.
Clarification I need. So many classifiers are there, like naive classifiers, like Bayesian classifier. Can you tell me and what situation which could be better?
Ma'am, you want me to, you are asking which is better?
Which is better? Based on what to decide among all these to consider for our work.
Okay, ma'am. Okay, ma'am. If you don't mind, can I answer this question at the after finishing this Python implementation?
No
problem, ma'am. Okay, ma'am.
No problem.
Okay, ma'am. Please don't mistake me. So next, it is about simple basic implementation. So whenever we are going for NLP related tasks, we can import the library called NLTK, which stands for Natural Language Toolkit. And this library can be used for whatever task that is related to NLP. Okay. And so what are the steps we do and when we implement the same classifier in Python is, first we have to import the necessary packages, whatever we have. Like I was talking about NLTK, right? Similarly, the remaining packages. Then you have to define a function to extract the features. So like the words which give you the sentiment, and preparing the training data. So what is the training data? Our training data will be in the form of documents and classes. And then you have to separate the data set into positive and negative. Then split the data set and extract the features and train your naive-Bayes classifier, and finally test your model with some sample input. So these are the steps or preparations which we are going to do before implementing in Python. Okay, now so packages, necessary packages. So since this is an NLTK application, you can directly use the NLTK toolkit. So just by giving import NLTK, and also it is a classification related task. So from NLTK.classify. And when it comes to the data sets, we have a lot of options. Either you can download a data set from some repositories like Kaggle, UCA repository, you can download it, or you can just manually create your own data set with some few columns. Or what you can do is, there are some data sets which is by inbuilt will be available in libraries. So similarly, in the NLTK also, we have a data set called movie reviews. So you can directly import from that. Import naive-Bayes classifier from NLTK.corpus, import movie reviews. That's all. The data set will be imported. Then what we want to do? We want to define a function to extract the features. Okay. So what are the features? We are preparing this word list. Do you remember? We prepared a table, right? Two column table. So one is the number of words, another column will be the number of occurrences. So for that, we are creating a function. So we are preparing the training data. So like labeling, whichever is giving you positive, that will be labeled as pos, and for the negative, we are labeling it as negative, neg, pos and neg. And we're separating the entire data set, like what are the data sets you have for positive. So that will be in features positive variable, and for the negative reviews will be in features negative variable. So two variables we have. Your features positive will store all the all the reviews, that is all the words that denotes the positive, and negative will denote all the reviews or the words that denotes to negative, feature negative. Okay, so we have two variables, feature positive, feature negative. Then we have to split the data set. So we can use the function called threshold factor. We can use that variable. So if it is 0.8, it denotes that 80% training and 20% testing. So this you can also change it this to like 0.7. So which means that 70% training and 30% testing. You can modify it. So we are just fixing with the threshold factor and multiplying that with the positive and negative threshold, because we are splitting the data set, right? So you just multiply. So the next one, we are extracting the features. So features train and features test. And we are printing the data points, like how many data points we are training and how many we are testing. We are just printing for the understanding purpose. Next, now here comes the hero of the application, that is the naive-based classifier. You just directly call the classifier. Okay, because when you work on with the simple basic classifiers, those will be available in the libraries. So you can directly give the name naive-based classifier, provided you have imported the libraries. Okay, now we are printing the accuracy, and let us see. And for that accuracy, you have to use the function nltk.classify. This is already we imported in the initial part of the code. We imported this, and now you want to print the accuracy, so you go for .util.accuracy. So we are training the classifier, and what it will print is, it will give you the in most informative words. It will give you. This is not mandatory, just for understanding purpose we can add this. Now we are testing the model. Fine, we have trained our model with some data, with the built-in data set. Now let us give a sample input and check whether the model is able to work fine or not. So we have got 4 input sentences. And finally, so it will give you the predictions, like how it is predicted and what are its predictions. It will give you for each of the 4. Okay, that's why we are using for loop. For each of the 4 sentences, it will individually classify what is that particular sentence belong to and what the accuracy is. Now you run the classifier and you print the output. If you see, so this is what. So we had the data points we had for that particular code is 1600 data points, and out of the 1600, so the test data points which were given is 400, because it was the threshold factor was 0.8 and the entire accuracy was 0.73, that is 73%. Now it is giving you the top 10 informative words from this particular data set and the predictions. So these are the inputs we have given, right? It is an amazing movie. So it is predicted that particular sentence is positive and giving you the percentage 61. Then next comes the next one. This is a dull movie. I would never recommend it to anyone. This is for negative and the corresponding probability. So that is nothing but the accuracy. Okay. So this is how the sentiment classifier is built using naive-based classification. Okay. So the very, the most flexible or comfortable aspects of your machine learning is you will have lot of libraries, inbuilt libraries, so you can directly utilize the libraries for different set of data sets. Okay, so any queries regarding the code or anything related with this coding implementation? Okay, madam. Okay, ma'am, let me come to the question that you have asked. Like which classifier is best? You were asking that question, ma'am. Am I right, Nandini, ma'am?
Yes, ma'am. Yes, ma'am. Yes, ma'am. Which can be chosen.
Okay, ma'am. So as far as sentiment analysis is considered, so we can perform lot of sentiment analysis, ma'am. For example, if you can go for a Twitter sentiment analysis, or you can go for movie reviews or product reviews, whatever it may be, different types we can perform, and we cannot say like only this will be the best. So if you take SVM will also give you the good method. If you take naive-based will also give you the good classification. So what are the things you can make different is in the feature extraction methods and in the feature selection methods, ma'am. So if we are concentrating more on those methods, like some improved classifiers. For example, we have for in the previous session we even discussing about some PCA techniques and all. So if we are concentrating more on the feature extraction and feature selection techniques, we can improve the classification rate, ma'am. So that's what, thereby we can improve the performance also. Like we cannot say this is the best, that is the best. So if you are asking me like which is the best, I would say all the algorithms are best as far as machine learning is considered. So whatever data set you are giving, everything will be handled. Everything will give you the final data, final result. So the thing that matters is the accuracy is matter. So if you can improve the accuracy by tuning the model, improving the data pre-processing techniques, improving the feature extraction models or feature selection methods, you can do that, ma'am.
Ma'am, sorry for the interruption. Shall I conclude that a trial and error method only I can identify among those?
Sure, ma'am. Sorry, ma'am. What method? What method?
Trial and error by applying various these classifiers. We can
Yes,
come
ma'am.
to
Yes, ma'am. Yes. Yeah. If we consider the previous researchers, whatever that is done as far as the sentiment analysis, everything will be like that only, ma'am. So if for someone for Twitter sentiment analysis, so if they would have worked with APIs, so they'll have got a good accuracy for SVM. The same for Twitter API. If we are going to work, we can improve the result in Naybase also. So it varies, ma'am. So it varies depends on the data set also, size of the data set, and also the methods whatever we are using. So if you want to improve the performance of a particular classifier, we have to concentrate from the initial, from the pre-processing, the extraction methods, everything we have to fine tune, ma'am, so that we will get the good performance.
Yeah, variants of that classifiers having its own complexities. So its own complexities like that variants. That is the reason why these are all that is variated. All classifiers are variated.
Exactly, ma'am. Exactly.
So as we are saying, if we do the changes at the beginning, like features extraction, the first stages that prior to classifiers, if we make the changes, then we can identify which is better than.
Yes, ma'am. Exactly, ma'am. Exactly. So, if you have, if you refer the some literature works that is already done, so everybody will say whatever the aspect their implementation is considered, they would
That
have
is
finally achieved a good result. Sorry,
whatever
ma'am.
they have taken, they are saying that it is working fine for their
Yeah,
work.
provided we have to just concentrate on their justification methods. So they would have some modifications in the what to say in the data set or in the pre-processing methods, whatever it is, they would have considered. And if you see the even the training set testing set ratio that might also give you a lot of differences in the result. So we are for example in today's example we discussed 0.8 as the ratio. So if you take 0.7, that accuracy may be improved. So at that point also you can justify. So there are a lot of justifications, ma'am. But whatever it is, you can concentrate more on the feature extraction, feature selection method. That will give you good results.
Yeah, being it is given as a black box, like it's a tool. The outcome of the tool only deciding that which is good, like. But internally, how it is being designed, I think no one is considered that much level.
Yes, madam. So if you just check on actually as of now, these sentiment analysis, everything is shifted to the next level. Like it is already started. Like implementing those sentiment analysis with deep learning techniques. So
Yeah.
if it is sentiment analysis, we can even say like if I go for this particular feature extraction method, yes, this is working fine. But if it comes to deep learning, we will be actually not able to visualize what is happening inside. But in the end, the result will be good. The result will be improved. So like likewise, if we just go for the next level learning, the things varies, ma'am. So if we can concentrate on the extraction methods and selection methods, so that will give you good results, ma'am.
So here in this, so here that work what you are explaining now,
Yes, ma'am.
how will it be applicable for sarcasm? That is a sarcastic uh, sarcasm.
Sarcastics. Okay, ma'am. Yeah. I
Sarcasm.
can understand. Yeah, the same
That
thing,
type
ma'am.
of sentiments, like
Sorry, ma'am. Sorry, ma'am.
yes,
Please come.
sarcastic sentiments.
Okay, sarcastic sentiments. Yeah, so that can be considered like under your neutral category. So if you want a separate other that sarcastic category, then we have to concentrate on the features only. Because so as far as this basic example is considered, we are considering only the words. The words play a major role here. So when similar to sarcasm also, we have to concentrate on the sarcastic words. Those sarcastic words will be a part of the feature set. So separately we have to concentrate on, and also we have to choose the data set also accordingly. So here we are working with supervised learning example. So your naive Bayes is basically a supervised learning. So if it is supervised learning means the data set should contain the labels. Like if you're feeding those set of inputs, all the inputs should have the labels, like whether this particular sentence belong to positive or negative. Okay, so similarly, sarcastic related data also should also be present inside the data set, so that it will be very useful for the training as well as testing, while testing both the time also. So we need to change that we need to concentrate on that particular data.
Okay, ma'am, I got it.
Okay, ma'am. So because here the words only plays a major role. Whatever the sentiment is, we have to concentrate on words. So if you go for some sarcastic, the data sets with some sarcastic related sentiment, that will be helpful for more understanding, ma'am.
Hello, one more question, ma'am.
Yes,
Hello.
ma'am. Yes, ma'am. Audible, ma'am.
Actually, this sentimental analysis that you have described is based on words, right?
Yes,
So,
ma'am.
ma'am, shall we provide this sentimental analysis for the voices also?
For the
Voice for sound.
Exactly, madam, exactly, we can do. So that will be in a separate category. So you're like this the sentiment, and if you consider basically as I was discussing with some variations, no, so those variations you could have seen. So we can also detect the sentiments from the voices which input as input. So it can be of anything, madam. Voices, it can be from the images, or it can be from the expressions, facial expressions. So we have lot of categories. This sentiment analysis is actually a wide area. So we have got different set of applications, ma'am. Obviously, we can do for voices also.
Hello, ma'am.
Yes, ma'am.
Good morning. Sorry for the interruption. Ma'am, actually, this is for a single language. Suppose if it is a mixed code, it contains tweets or something, that messages contains mixed code, both Tamil and English, or 2 or 3 languages, means how can we classify? It's a mixed code means.
So if it is a mixed code, we have to maintain a separate set, ma'am. Like if it is when it comes to tweets, what are the things we will be doing is, so we will be concentrating on lot different parts of the text. Like we will be having some punctuations, we will be having some emoticons, how to say, emojis. We will be having some emojis. So we will be maintaining a separate set of list. So if it is emojis, it is also like a stop word, right? So we need not to worry about the emojis and all. So those things will be eliminated. And regarding the
I'm not asking about the punctuation as stop word symbol.
And that's what I'm coming step by step. Yeah, I'm
Tamil and English languages. That's what contains both the languages means. Shall we convert into one, or how can we classify the 2 languages? Whether we convert into a single one, or how should we do? That's
what I'm coming step by step, ma'am. So those like those things will be done in pre-processing itself. So we will be eliminating. Similarly, so we have to maintain the training set which contains the Tamil languages also. We have to maintain as a separate list. We can just convert those words. So if it is both English and Tamil, it is actually a complex process. So we cannot expect that the future input will be only in English or only in Tamil. So if it is the previous inputs, what we can do, we can train the machines accordingly. So when it comes, a new word comes into future, so it will be difficult for the machine to predict. So what we can do is, whenever other languages are like notified or given as input, we can just convert into English. We can just perform a text translation there. So, and then we can go for the sentiment analysis.
So that is also a very big task, is it right, ma'am? Because most of the studies and surveys and all, people, they used to do mixed code. They prefer mixed code technique. That's why I'm asking. So for each and everyone, we have to check the symbols and each and every languages we have to check the symbols and then convert into a single one.
Yes, ma'am. Because those things we have to just done only in the until the data pre-processing. We should have completed all those tasks, ma'am. That's why I was talking from the emojis itself. So we do all those things in the pre-processing itself, so that it will be easy for us to analyze further.
Okay, okay, ma'am. Thank you, ma'am. Thank you so much.
Okay, ma'am. Thank you for all the wonderful questions. Now let us come to the questions in the chat box. Tools for doing. Okay, I'll just share some of the online tools, ma'am, that is available. I just share at the end of a session. And how the negation is handled in NB classifier. Okay, and okay, fine. So how the negation is handled. So basically, like if you come to negation handling, we can give some set of words. Like these are the words that can be like not, couldn't, haven't. Those can be identified, and we can just remove those words. So we can maintain a separate dictionary or a separate list for those things, for those separate words, and then we can remove those words. So that's why we have the separate step for negation handling, right? So in that, for negation handling, we can maintain a separate dictionary or a list which stores the like words with not, never, n apostrophe t. Those can be maintained as a separate dictionary, and when the words occurs, we can just remove that. Okay, Ms. Deepali, is that okay?
Yeah, but that will not remove, that will just remove negations, right? It will not detect the emotion properly.
No. See, negations, we remove only not those things. So when it comes to the sentiment, we will be concentrating more on the words. For example, for if you have the word like we have a word awkward. So when you see awkward, so it is actually a negative sentiment. So based on that only we are going to find. So these not negate is that will be removed separately, and we'll be concentrating more on the words which gives you the negative sentiments.
Right. So if like say, if I say your presentation is not excellent, so if it is then excellent, that particular statement will be treated as positive, right? Because it has excellent word.
Yes.
So not excellent should be treated as negative, right?
Yes. That's what. So what do we do is, that's why we go for the corpus representation. So for like we also take care of the frequency of representation. So for the one scenario, okay, this particular, it may be wrong. This is not it is not excellent presentation, may be wrong. So when you go for the multiple sets across multiple sets, so when it compares with all the documents, so it will give you some different set of classification. So you will not get the negative. That is why we are dealing with multiple set of documents. So now when you ask, this is just a single sentence, but in your training set, it will be containing multiple sets, right? So when you just compare it, when the machine compares with multiple sets, so you will get, there are a lot of chances for the modified results. And also it is not excellent presentation. So it is like we'll be giving the machine along with the label also when you give the training set, right? So when you give the training set, it is not an excellent presentation, will be in the negative, in the negative sentiment. So when you just train the machine or with multiple sets of labels, so obviously that you can have a lot of modifications in the result, leading to the good accurate results.
Thank you.
Okay. Okay, so fine. So regarding the online sentiment analysis tools, so we have something called as Monkey Learn. Okay, so monkeylearn.com. Here, this particular, you can just, what you can do is there is some option called try Monkey Learn for free. Okay, there will be an option. You can just sign up and access its services. So here they have given the steps also, like how can you do the steps, how can you do the sentiment analysis. So you can choose a model here. Okay, so they have given the step-by-step instructions. So you choose your model, and you can choose your classifier also. So here you could see the classification. They have topic classification, sentiment classification, intent classification. So you can choose corresponding classifications. and you can import the data. So if you have the data in the form of CSV or XLS, you can upload, or you can directly upload the API like Twitter API for or Google API, whatever it is, you can directly import, and you can use the data library. So by default, they have some random data sets like hotel reviews, some data sets they have. So you can also use that also from the data library. So you choose the data, okay, and then so this will be the sample data you could see, and you can train it. Fine. So these are this is actually for Twitter. They have given Twitter sentiment analysis. So you can train the machine. So can you see now a new just see when you are at Twitter's when a new tweet comes, it automatically says whether it is positive, negative, or neutral. Okay. So this is training. Like we are we are saying like this is positive, this is negative. Like we are saying the machine, we are making the machine train, and you can just test the same classifier by giving a new text, your own text. Okay. And it will give you what tag does it belong to, and what is the confidence, how much amount that is true, or that machine is confidence about the result. Okay, fine. So this is one thing for monkey learn. Another one is like you have for Amazon AWS. So they have their own sentiment analysis for reviews, for tracking the reviews. So this is their architecture overview. So please check in the website aws.amazon.com. So you can check here. So here also they have given you the step-by-step configuration, like how can you do. So these are the steps. These steps are so good and very clear. You can follow these steps. So they have also have some set of data sets in the form of text format. You can go and select this. You can add your, or if you also want, you can add your own files. So select files, set permission, properties, and you will get the review. So these are the 4 options they have got. So the steps are actually very clear. So you can try this 2 things. So there are a lot of tools available. So as far as I have just analyzed, these tools are good, and you can when you just try to work on with these 2 tools, you'll be able to exactly understand what is sentiment analysis and how it is happening. Okay. So you can try monkeylearn.com. So monkeylearn.com or AWS in Amazon Web Services. So that I think, so these are the reasons why should we go for sentiment analysis. Obviously, it solves business problems. From a business point of view, it is helping a lot of manufacturers or sellers to understand the reviews or customer behavior analysis or feedback analysis. They can do lots and lots. And these are some of the interesting applications which we have currently. For example, Google performs sentiment analysis. Like for example, if you just check about any hotels, the reviews, the profile search, everything will be automatically just displayed inside in the website itself. So this is one Google's excellent sentiment analysis. And this is, as we discussed, it is Amazon's their own sentiment analysis for checking the customer reviews. Okay. And this is overall, these are the wide set of applications across we have for sentiment analysis. So everywhere it plays a huge role. So that's all about the basic concepts of sentiment analysis. So like with this, you can perform a lot of analysis and it is used everywhere. And as one of the professor asked, it can also perform sentiment analysis from voice or speech or images or text. And when it comes to emotion recognition, that is another huge topic. You can detect emotions from the your ECG signals, EEG signals, and EMG signals, and your skin temperatures. Everything is possible with for emotion detection. So this sentiment analysis is actually a vast and wide topic. Okay, and whatever we discuss is just to give you a basic idea of how it is working. So we all are working with applications of sentiment analysis in real time, and this is how it is happening inside. So just to give you an overview. So these are some of the references you can go. So if you want to understand about the libraries that you have, scikit-learning, you can go for this website. And these are the sites that gives you clear understanding or clear explanation regarding machine learning applications, whatever it is. Regarding algorithms or some applications, everything are so clear in this. So you can get a lot of learning from these references. So any other queries?
Okay. Thank you for your wonderful and excellent presentation, madam.
Okay, sir. Thank you.
Participants, any queries? Otherwise, I will stop the recording. Any queries? Okay, thank you.
Wonderful presentation, madam.
Okay, ma'am. Thank you